So last class, we were talking about value at risk. Okay? So we talk about value at risk. We tried to understand what is the meaning of this, how we can understand what we call an extreme S scenario, some kind of extreme S scenario. So, so we said, suppose we have a portfolio that has a standard deviation of, say, $2 million, okay? Then with a standard deviation of $2 million, this is the volatility of the portfolio. We said we would like to know what is the value at risk. We would like to know to what extent we can determine exactly how much money we could be losing. Okay? So what we said last time is, let's begin by assuming that the losses of this portfolio are normally distributed. So they are normally distributed like this. Suppose that the average, the mean is 0 for this. Okay? So remember, these are the losses. So here we would be talking about losses. Here we would be talking about negative losses, which are gains. Okay? So assuming something like this, we said, suppose that losses are normally distributed with mean 0 and a standard deviation of 2. Okay? So in this scenario, we ask ourselves, how can we find out a number that we are going to call the value at risk, okay, such that we can say something like, what is something really bad that we can expect from this portfolio? Okay? So we said the idea of bar is that with 99% of confidence, 99% of confidence, I like to know what is the largest amount of money that I could lose with this portfolio within certain amount of time. Suppose one day ahead. Okay? So we calculate this number last time. Under this assumption, we said, so the value at risk, I'm just summarizing what we learned the last class. So the value at risk is going to be what? How do we write this formula here in this case? It's going to be the standard deviation of the losses time the normal distribution value at this 99%. Okay, we call it this X%. Okay? So under this assumption, we showed it last time, as you remember, that this is going to be 2 times this value. In the case of 99% of confidence, that means we are going to have here 1%, and here we are going to have 99%. So these are the losses, these are gains, these are losses. I'd like to know exactly what is this number. Okay? So in this case, this number is going to be, so this is going to be 2 times how much? 2.33 coming from the standard normal. Okay? So coming from the standard normal, we know that this value is going to be then $4.66 million. Okay? So in this case, we said this number is going to be here. This is what we call the value at risk. It's going to be $4.66 million. This is a very interesting number. What we are finding then is that with 99% of confidence, which is the probability here, we can say that our portfolio will not lose more than $4.66 million, okay, in the next day. So this is one way to measure an extreme S scenario for our portfolio. And this is what we learned in the last class. Okay? Is there any question about this? Is there any question about what is the value at risk? Do we understand this point? This is a very important concept in risk management because it allows you to somehow, in just one number, understand what could be the behavior of your portfolio in the near future. Okay? So this is a very powerful concept. It's widely used because it gives you, in just one number, one idea about the behavior of the portfolio in the near future. Okay? So it is important because it will also allow you to integrate many different types of risk in just one number. Okay? So just for the last time, remember this. 4.66, that would be what we call the value at risk. Okay? So we are risking this amount of money in the near future, one day. In what sense we are risking this? In the sense that with 99% of confidence, we can say that we can lose at least $4.66 million tomorrow. Okay? That is a very important statement for the behavior of our portfolio in the near future. Okay? So the first thing we need is to understand what is the concept. Next thing we are going to move now is to try to explain how to calculate this in different scenarios. Okay? So what we are going to do now is next we are going to focus into the idea of market risk. Okay? So market risk is one type of risk that we face. Traders face this type of risk. Banks also face it. And companies also face it. So this kind of risk that is involved by the behavior of the economy is what we call market risk. As you learned in previous classes, this sort of risk is very hard to, it's impossible to diversify. Okay? You just have to live with this risk. And somehow it will be very important to know what can happen to our portfolio due to this type of risk tomorrow. Okay? If this is just one day bar that we are trying to estimate now. Okay? So there are several approaches to calculate this number for our portfolio. One strategy is what we call here the historical simulation. Another strategy we will learn in this class is what we call the model approach. Okay? There are several types of products that we can find in the market depending on what is your type of institutions. Especially, this is a very important concept for banks. So it's very important for a bank to know what is the market risk and what is exactly the value at risk. Okay? As I said yesterday or in the last class, we need to determine exactly what is the value at risk for the bank. Like how much money the bank could lose tomorrow in a very extreme scenario. How much money they could lose, and give you the amount of losses that they could face, for instance, in the loan portfolio. The question is, suppose that I am expecting to lose $4.66 million tomorrow in my loan portfolio. The question is, do I have enough capital to support this loss? Okay? So regulators are very concerned about this number. So this value at risk is not only important for bankers or for traders or for the risk managers, it's also important for regulators. So regulators are always trying to see whether or not the bank is able to cover this, okay, as we will see later in more detail. Okay? So what we are going to do now next is we're going to try to find how to estimate this value at risk using what we call the historical simulation approach. Okay? So let's go into the detail of this.